All right, so let's start off with a couple different things here. We're going to look at some reasons for air filtration, okay? And the primary reason that we look at air filtration is going to be to keep the equipment clean. That's really the reason we want to start with air filtration, and that's the minimum filter that we want to put into the system. Now, the next reason beyond that is the building air or for the occupants of the building. And that's the next step above keeping the equipment clean. So we're going to really talk about that a little bit tonight, kind of some of the different standards and things that are out there for the filters and what you can get into for selecting filters. But when we're talking about occupants, we need to start asking about dust. We need to talk about allergies, things like that to the homeowners. Do they have that problem? And there's some other things that we need to look at as well as just filters, because just putting a filter in is not going to be a magic bullet. We need to make sure we have the right size filter in there as well, which is very important for our equipment, because we need our equipment to run properly and we need it to last a good long time to make sure the customers stay happy. Okay. Now, we'll take a look at a couple things here on your slides. If you're following along on the slides, or you can see here on the TV, talking about Merv rating. Okay, what is a Merv rating? Well, the Merv stands for Minimum Efficiency Reporting Value, and that's an ASHRAE standard. I believe it was brought out in 1987, somewhere around that time frame, and it goes from 1 through 16. Okay, and the lowest on the low end, number 1, is they don't catch much of anything. So we look here on our scale, we're talking 1 to 4, 3 to 10 microns, less than 20% of those size particles are captured by that filter. So the Merv rating really tells us what size particles, okay, we are looking at and how much of them they're going to capture. All right. Now if you look down here, we're talking about 1 micron. Right? 1 micron is equal to about 0.000039 inches. So get out your Stanley tape measure and measure that out, right? You know, we really can't. So moving on up the scale, a pretty standard air filter. If we're looking at a normal, like just a 1-inch pleated air filter, something like that homeowners would go to the hardware store and buy, you're going to be looking in that Merv 8 range. Okay. Down here we're talking about poly filters, washable filters in the kind of that 1 to 6, or maybe even something like a fiberglass filter. But it doesn't do a lot of filtration for really fine dirt. It catches big stuff, but not real fine stuff. The good thing about these filters is they're very low resistance to airflow. You can move a lot of air through them with very little resistance. So we're going to talk about that as well. All right. Moving up the scale, the higher that number gets in the Merv rating, okay, the more stuff it's going to catch. All this is available online. You can do a internet search for Merv ratings. You can see all this stuff and find that out. When you want to know more information about it, dig into it a little bit deeper. But good things to talk about with the homeowner. You also need to know, again, what size stuff is in the home. So you may need some way to measure that. Now there's different ways to measure that out there. We're not going to go into those tonight because we don't really have time to get in that deep in things. So again, take a look at that. Remember that size, the micron there as well. Now, HEPA, this is something we've heard about. What does HEPA stand for? And a HEPA filter is a high efficiency particulate air filter, or HEPA filter. All right. It takes out 99.97% of particulate 0.3 microns and larger. So it's a much better filter at capturing airflow, or capturing particulate matter as the air flows through it. It's a really efficient filter at catching stuff. It'll catch a lot of stuff. One of the challenges with this is, though, that when it catches a lot of stuff, it has to be very restrictive to airflow. And the typical fans or blowers that are in our equipment won't pull the air through that filter. So HEPA filters, when they're used in a standard residential or light commercial system, they're going to have their own fan. So this we call a HEPA bypass filter, and we'll talk a little bit more about how that's installed later and where it works. Okay. Now, let's take a look at some filter selection. Now we have a whole, I'll be showing you some different filters here as we walk through this, right? This is a key thing though to note. When you're selecting a filter, part of this is going to be selecting the size. Filters can be larger than the opening on the equipment. This is a very, very important piece, and I'll show you why in a little while. Right, now, the first thing we need to look at when we're selecting a filter is going to be our customer's needs. What does our customer actually need? Do they just need the equipment to be kept clean? Because if we get dirt on the blower wheels, if we get dirt on our secondary heat exchangers in a gas furnace, we get dirt on our cooling coils in cooling mode when it's wet, turns into mud, we lower our airflow, we lower our heat transfer, the equipment can't run right. The equipment's not going to operate the way that it's designed to, and it's probably going to have a shorter life, so the customer isn't going to get what they paid for out of it. So we need to make sure we have a good enough filter in there to keep the equipment clean. Now, if the customer needs something else, the customer needs more to clean their air, we've got to be concerned about that. So customer needs, equipment needs. What does the equipment need? Minimum. But I put the customer needs first because if the customer needs something higher than just the minimum for keeping equipment clean, which is typically about a Merv 8, will keep the equipment fairly clean. If we go higher than Merv 8, the equipment's going to stay clean as well. So that's covering that. The last thing we have to look at is physical space needs. If I need a large air filter, I have to have the physical space to A, be able to put the rack in, B, put enough ductwork in to get the proper air to the filter, and C, I have to be able to change that filter, meaning I have to have physical space in front of the filter rack to be able to open the door up and slide the filter out all the way and not have to bend or crinkle or crumple that filter just to slide it into the filter rack. As a lot of you probably have, being in the field, you see these problems a lot. I've run into filter racks where I've had to bend them just to slide them into the filter because somebody built a wall in the way or somebody put something in a hanging unit in the way. It's not good on the filters. If we're putting in a damaged filter, there's a good chance for bypass. So when we put a filter in a rack, we need that rack to seal tight on both sides of the inlet and the outlet side and all four sides all the way around. That way we don't get air bypassing around that filter. We need to make sure it's tight in that rack. In fact, JD was just asking me a question about that earlier, about what would fit and how tight should they be. The tighter the better, because that's less air that's bypassing around the filter, which means all the air that's going through the filter is going to get filtered, rather than pulling dirt around it, which again gets the equipment dirty, which is what we're trying to stay away from, of course. Okay, so that's kind of the first step in selecting a filter. You've got to know those three things. Now, this is a big thing on selecting a filter. We need to know how much air is required to go through the equipment. Right. Put a couple rules on here for you. Typically, we're looking at air conditioning and heat pump, about 400 to 450 CFM per ton. Typical gas furnace is going to run about 150 CFM per 10,000 BTUs of input. All right. So 150 CFM per 10,000 BTUs of input. That's going to give you an idea of how many CFM you need to run through that filter. Now again, filters are often, should be often, and can be larger than the opening on the equipment. Now we need to know the pressure drop. And pressure drop is measured in inches of water column, and what pressure drop on that filter represents is resistance to airflow. Now, as we're moving air through the system, the blower has to work harder. The more resistance, the harder that blower has to work. I like to think of it as trying to drink a milkshake through a regular straw, through an oversized straw, or through a coffee straw. Okay? The smaller the straw, the harder you're going to have to work. Well, the smaller the straw in, or the duct, or the air filter in that system, the harder that blower is going to have to work. Sometimes, depending on the blower style, it's going to use more energy. Sometimes it's just not going to move enough air for the equipment to operate properly. Again, shortening the life of the equipment, potentially damaging things, costing your customer money. Okay. Now, whoops, let's back up there one. When you're operating an ECM, electronically commutated motor, you want to run that at about 70% of its maximum capacity or less. Okay? Less than 70% of its maximum capacity. The example we put up here, if you have a max total external static pressure on the box, rated on the box with the blower in it, 0.8 inches of water column. You take that 0.8 times 0.7, you really need to keep that total external under 0.56 inches. And that's going to be for longest life of the blower motor as well as less energy usage. And if you can get it below that 0.56, that's great, that's even better. The lower you can get that number, the better off you are. But there's limits to what we can do there. We're going to have some resistance. It's designed to work against some resistance. It's not designed to work against a lot of resistance. I see a lot of systems rated at that 0.8 or a 0.5 that are running at a lot higher resistance. They typically have lower airflow. They're typically having problems, maybe breaking things, and that's not good for the customer. Customers don't like it when their equipment breaks down and it doesn't work properly.
Hey, Eric, I got a question.
All right, JD,
First
got a question.
William wants to know, where do I find the rated static pressure drop across a filter? Is the static pressure drop listed anywhere?
Ooh, that's a tricky question, William. I like it. Now, the rated static pressure drop on filters can be difficult to find. A lot of manufacturers don't publish it, but I'm going to give you something tonight here on the next slide. So keep your eyes open on the next slide. But really, you need to go back to the filter manufacturer because each filter is slightly different, okay? I'm going to give you a generic chart here that you can download for Merv 8 filters that I did some research and looked at several manufacturers and kind of came up with some average numbers for you. But when you get into higher Merv filters, you need to go back and you need to talk to the manufacturer and find out. Now, a lot of manufacturers rate their filters at a specific feet per minute of velocity and don't necessarily rate it at the pressure drop that we are looking for a lot of times. Because we really need, in the residential and light commercial world, we'll talk about it here in a little bit, okay? We need to keep this at about a 0.1 inch or less of pressure drop, all right? So if you download this slide, this will be in your download section on the website there, or you can see it on this slide here. This is for Merv 8 pleated, and it gives a bunch of common sizes. At a 0.1, this shows you the CFM for 1 inch, 2 inch, and 4 inch thick filters. So that allows you to give a good idea of where the filter drop should be or will be on this. Okay. It also gives you that airflow down there for gas furnaces. Okay, it gives you a couple other things on here. But again, go back to that manufacturer of the filters and ask for it. I've been asking several filter manufacturers for pressure drops or for rated CFM at that 0.1 pressure drop because that's typically where we need to design at in the residential and light commercial when we're talking about split systems and an external filter rack. All right. So we kind of covered that right there. Again, handy little chart just to have around when you're designing, when you're looking at something. And again, it's a generic. Always go by the manufacturer's filter charts or the manufacturer's pressure drop charts first. But if you can't find them, jump to this, and it'll get you real close.
Eric, I got some more questions.
All righty, sir.
Tyler wants to know, what do you guys think of the April Air 213 and 501 filters for proper filtration over the 1 inch high Merv Filtrate 3M filters? Do you have a preference, April Air over 3M?
Well, again, it all comes back to the Merv rating. Okay, what is the Merv rating? What are we trying to do? And what's the resistance or the pressure drop across that filter? Any filter can be the right filter as long as it's sized correctly for the application that it's looking at. There are definite advantages some days to the April air filters. Again, I'm not real familiar with their model numbering system, so the numbers you're throwing out there, I'm not 100% certain on what those are or which filters those are. There are some nice things about them because a lot of times they have a collapsible media where it's much smaller and easier to carry in a truck. It looks something similar to this, where I can have a really big filter in a really small package, but when I start stretching it out, there's a lot of filter media in there, okay? And that's not an April Air, that just happens to be one that we have here tonight. We grabbed to bring in just kind of as a show and tell to stretch things out there. Now, it's funny you bring up the other brand because this was something I found recently. Some brands of filters are actually putting pressure drops printed on their filters. I thought this was really cool. Now, I'm going to back up one slide here real quick. All right. Take a look at this. Now, the filter on the next slide is a 20 by 25 by 1. Okay. So look at the 20 by 25 by 1. We're looking at about 625 CFM, right, on this Merv 8. Now, this filter happens to be a Merv 12, right, when I looked it up. So we're looking at about a 0.09 pressure drop instead of that 0.1, but we're at 515 CFM through that at that 0.09, which is really close to a 0.1. 0.09 is a fine static pressure drop. But because this is a higher Merv rating, it moves fewer CFM through it. Now this also has a lot more pleats in it than a typical Merv 8 filter does. So it is going to move the air through there at a greater deficit to pressure. So in this, if we need more airflow, we need a bigger filter. We need a larger size, right? So this is where I go back to that. The air filter typically should not be sized for the opening on the equipment. I am immediately suspicious if I walk up to a piece of equipment and I see that the air filter is sized by the opening on the equipment. I am going to be suspicious of that. I am automatically going to start testing and looking to see if there is a problem because I want to know if there is or there is not a problem. I don't care if there is or is not. I want to know that there is or not, because if I know there's a problem or if I don't know there's a problem, I can take the appropriate actions and make the appropriate recommendations to the customer.
Got some more questions for you, Eric.
Alrighty, sir.
Robert Lee wants to know, can you use the fan law to convert to actual pressure drop based on the CFM you are running?
The fan law.
I don't know what the fan law is.
Yes, I am. I'm thinking on that one, and it depends on where you're taking the pressure drop at. I'm going to say I don't know off the top of my head.
Okay. Fair Stanley wants to know, when's the right time to replace the air filter based on the standard you were just talking about?
Ooh, right time to replace. We're going to talk about that later towards the end of the presentation here tonight, so keep watching.
Gotcha.
All right. Any more? We are good. Moving on. Thanks for the questions. Really appreciate it. Okay, so this filter happened to be 20 by 25 by 1 Merv 12 installed on an 85,000 BTU hour furnace that needs about 1275 CFM. Right? So if I'm looking down here, looking across this pressure drop chart, I got 1280. It's pretty doggone close. That pressure drop on that filter is going to be about a 0.3. So 3 times what I really want to have at that 0.1. So again, you really have to know what the pressure drop is in order to size the filter properly. I would need, close to 3 of those filters to do that right. Now, filter pressure curves typically aren't linear. If you look at them on a graph chart, they're not a straight line. They're not that linear line. They're going to be a curve on there. So it doesn't always match up because we're talking about 515 at 0.09 and 1280 at a 0.3. All right. Now, testing the pressure drop on a filter. Testing the pressure drop on a filter is pretty simple. We need a dual port manometer, right? And we need to put our probes in on both sides of that filter if you're talking about a ducted system. And we're going to talk about a lot of different configurations, where to put the filters, some different things that need to be done to make filters work the way they're supposed to. And really, we're going to talk a little bit more about near unit ducting tonight too. Okay, that's something else that's kind of a side topic in here because it ties in. The two things tie in really well together. But we need to take that pressure drop. So our negative pressure needs to be on the equipment side where it's a lower pressure. Our plus or the higher pressure port needs to be on the inlet side of the filter. One key thing to note on these, the airflow needs to be coming straight into that filter to be able to work properly. If that airflow is not coming fairly straight into that filter, the filter is not going to get the full effect. And we'll talk about that, and I'll show you some pictures here in a little bit.
Eric, I got a quick question for you.
Yes, sir, JD.
What Robert wants to know, or Ricardo wants to know, what Merv rating do electronic air cleaners belong to?
And that depends on how clean it is, and it depends on the electronic air cleaner. They, I don't think, fall typically under the Merv rating. Some, I think, might have a Merv rating on them. The electronic challenge I find with electronic air cleaners is that they get worse filtration the dirtier they get. So they start out clean, and their filtration efficiency tapers down as they get dirtier. Whereas if we're talking about a pleated style or a media filter, something with a media in it, this actually gets more efficient as it gathers dirt on there and it catches more because the holes get a little bit smaller.
And another question from Ferris, he wants to know, do the pleated air filters or any other filters create any air turbulence?
They can create some air turbulence, but I find a lot of them tend to straighten it out a little bit. It depends on the situation and where they're installed and how that filter is coming in there. Because yeah, they're going to create and they're going to change the pattern of the airflow because it's not going to come straight through that filter, right? It's going to hit that filter and it might kind of hit it at an angle and work its way through there. But it's not going to, I won't say create a bad turbulence in the air, no. Right.
I got another one.
One more.
From a different Robert.
All right.
Wants to know, most apartments have slanted evap coils built up in the wall, and there's air, no way to come straight in. How do you overcome that?
So slanted evap coils, apartment units, you want it as straight as possible. You can't always get it. It depends on the installation, and it depends on how the filter rack is installed there. I like to have as big a filter as possible. And if you have a slanted filter rack and the air is coming straight up into this, I want the pleats running this direction, right? Not necessarily across that. And we're going to talk about that here in a minute. Okay, here's another measurement. So this is a little bit different type of a duct system. We're talking about a filter grill where your filter is out here at the grill. Now you can have multiple filter grills on one system. But we need to take a static pressure probe, right, and put it into, kind of through the filter somehow, and take a measurement on the back side of that. And then we need to measure the pressure out in the room. One key thing to note on any system using a filter grill like this, right, you need to have everything behind that filter sealed all the way back to the equipment. Because this whole duct in here is under a negative pressure, meaning it's below atmospheric pressure. So if you bring air in here and you filter this really well right here, but you have a lot of leakage in that duct back here, all right, you're going to suck dirt into that duct. It's going to get the equipment dirty and blow a bunch more dirt back out into the house. This is a really convenient place to put things if you have in markets where they have package units, they sit outside the house. Or if you have units in attics or a crawl space or something like that, it's a great way to do it. You just have to make sure that that duct is sized properly as well as sealed very, very well. You want to do a duct tightness test on that to make sure you've got as many leaks as possible as sealed up on that duct. Okay, and again, we want to look at that kind of that 0.1 inch range on that filter there. Now, let's get into talking about different system types. Okay, this is what we see a lot in a horizontal system. Size that filter rack right for the same size as the equipment. Sometimes that duct is even pinched down smaller and will expand as it comes into the filter right there before the filter rack. This is a place where I'm going to make sure I test that because I want to know what the drop is across that because I'm going to look at that filter. One of the things that happens a lot of times is when we as technicians or we install it with a certain size filter. Maybe we put in a Merv 8 filter. Well, then the homeowner goes out, they go to the hardware store, they have some allergies and they say, oh, I want an allergen filter. Well, then they drop a Merv 12 in there, a Merv 13, something higher that they can find. The pressure drop changes. Well, that affects our system operation, right? So we need to have that communication with the homeowner. We need to make sure that before we put the system in, we're sizing our filter racks for the correct airflow. And guys, guess what? A bigger filter isn't going to hurt you. If you put in a little bit of oversize, maybe they want to upgrade to a higher end filter or a better filtration filter later on down the line. A little bit bigger filter rack is not going to hurt. And this is what that would look like, right? So we'd make a transition here. Metal, duct board, however you need to do it. We need to make sure that the filter surface area is accessible to the airflow. We really need a nice long plenum coming in that's fairly straight before that, if you have the space. If you don't, we'll look at some options for that. We want that air coming as straight as possible into that filter. Next slides, we're going to talk about the straight air coming in. And then we want a nice transition down to the inlet of the equipment so that we can bring that air down into that inlet. The slower the air goes through that filter, by making this bigger, we're going to lower the velocity a little bit. And that air filter is actually going to be able to catch more because the air is going slower through that filter. Now, this is something that happens a lot, and I've seen this a fair amount in the areas that I've worked. We have a lot of gas furnaces, a lot of them are upflow, and a lot of them are put in closets, and they're really tight. We see a really small return drop coming down here. We've got a filter slammed right up against the side of the furnace. Most of the time it's sized to the opening on the furnace. And every one of them is too small. Unless you go throwing a fiberglass filter in there like so, well, that doesn't keep the equipment very clean. We end up with a lot of dirt on the equipment because of that. So a lot of people will throw a pleated filter in there, and then the pressure drop goes up. And then we start having airflow issues and comfort issues. And then we start having things break, and then customers get unhappy. One of the things that happens on this, though, is, guess what, guys? Air doesn't like to turn corners. It's going to come down here, and if you've ever pulled a filter out of one of these and seen this phenomenon, you'll have dirt loaded up on the top of all the pleats, and the bottom of the pleats are going to be nice and clean. If you got a white filter, you're going to see dark on the top, light on the bottom. That means that that air is not turning and making that corner to come straight into that filter. And you're really only using about half of the filter surface area, which is a problem. Because again, if I'm only using half of that surface area, and my pressure drop was already too high if I used 100% of the surface area, what just happened to my pressure drop? A little bit higher. Cranking it up just a little bit, right? So what can we do to fix that? Well, let's look at another picture here. Here's a real life picture. Thank you, David Richardson, for sending me that photo. This came out of the furnace it's sitting on here, and the return drop's over here, and it's got a perfectly sized filter rack in there. But the velocity was coming down here so fast, and that air would not turn that corner, right? So it wasn't even using the top part of this filter. wide open, not blocked at all, but it wasn't using the top part of that filter because that air would not turn and go straight into it. Okay, so that's just a great visual for you to be able to see that. I really like that picture. I wish I had some of the pictures of some of the filters I pulled out like that, but I don't. Yes, sir.
Got a handful of questions coming in.
All right, we got questions. We like questions.
All right, Jess wants to know what happens exactly if a homeowner puts in the air filter backwards, like against the airflow, upside down or wrong way.
Well, so a couple things can happen. One, it's going to filter something. However, when you put filters in and you put them in correctly, right, we've got a metal mesh typically on the back side of that filter to keep the filter from collapsing out. So if we put that filter in backwards, a lot of times what's going to happen is the air is going to push on this metal mesh instead of go this way. It's going to push into it, okay, and it can potentially collapse that media out into the blower compartment if it's too close to the blower compartment. You have a lot more filter collapses that way. Depending on how the media in the filter is designed, it might not filter quite as well. Depends on if there's any kind of an electrostatic charge or a sticky media in there. Sometimes they put a sticky piece on that media to help stick the dirt to it and grab onto it. So it really kind of depends on the filter. Hopefully that answered the question.
It did. Got another one here. When you were measuring negative and positive pressure, Ricardo wants to know how far should those test probes be away across the filter media?
Well, you want them fairly close, but you need to have them in some clean air. All right, because if we have we're using static pressure probes, right? They look like a little hook, and they have holes in the sides of them. And if we get the air pushing in on that sides, it gives us a false pressure reading because we get velocity pressure. We really want that air flowing straight at it or straight across it this way, either direction. Typically, you want that pointed into the airstream so the air is breaking over the tip of that static pressure probe like that. But you need to make sure that it's not in a place that has a lot of swirling vortexes. So you don't want to put it like right close to the fan inlet where it can actually swirl that air as it's going into the side of the fan housing. You want to back it away from that. And you really don't want to take it right in the middle of a corner. Typically you want to take it just before a corner or a little ways after the corner.
Ferris wants to know, he said he's seen a few systems that the customer has more than one air filter, one after the other. One like a 2-inch air filter thick to get the 4-inch thickness. Is there an advantage or disadvantage of this kind of setup? Is there any gain in the Merv rating?
Well, yeah, you're going to gain Merv rating because you're stacking filters. So it's not super additive, but the second filter is probably going to catch some extra stuff because the first filter already caught some, so the second filter is going to get to catch a percentage higher of that. So if you add the percentages up, you're going to catch more stuff going through. The downside is that adds a lot more resistance to it. So it's really a bad idea to do that unless you design the system for that or you design the air filters to be stacked like that. Because otherwise you're going to add a ton of resistance to it. You're pretty much going to double your resistance at that point. I'd have to look at the chart. I have to try some tests because they're really not charts designed to measure stacked filters like that.
And last one right now, Constantino wants to know, to lower pressure drop, can I put a thicker filter, 1 to 2 inch with same size?
Yeah, so go back to that chart that I gave you. It's in the download section that we looked at earlier, and you can see where the thicker filters, in the Merv 8 range that I looked at, typically the 2 and the 4 inch were about the same pressure drop. They were very, very close, within a couple CFM at that specific pressure drop. But definitely increasing from 1 to the 2 inch made a lot of difference. And the reason is, when we look at that, right, we're thicker here, so we can add more pleats in here because the depth is more, so we can up and down more and have that in the same square inches of area of filter rack inside the duct. Good question, thank you.
And one more.
One more, all right.
Oh, I think you answered it. Michael wanted to know if he can get that picture you have on the screen, but that's in the download section.
Yes, that's all in the
slides.
download section.
Yeah.
Absolutely.
Gotcha. Go
Absolutely. Download the slides and it's all going to be in there.
You're good.
Okay. So, right, got to turn that air. How do we turn that air? It's a great question. Right? One way that we can do this is with turning vanes. Okay? These are scoops that are put in that duct. And when the air comes down here, right, it tells that air to make a turn. I like to think of this as a car. We all drive vehicles around. We can't take, if we're coming right down this side in that vehicle, we can't make that hard turn in our vehicle. We're going to go way out here, right? Just like we saw in that last picture. Now, if you think of the old slot car tracks, we can make some pretty sharp turns in slot cars. Or if we're getting into a rail, you know, like a train or something like that, where we're actually on rails, we're being held in there. So what each one of these does is it takes a little slice of air and it turns it and it gets it going straight into that filter. This helps out a lot. I've lowered static pressure on a lot of systems just by putting turning vanes. Now, if you can expand the size of this ductwork out here and lower the velocity because you're putting a little bit bigger ductwork in, it works even better. Turn that and get that going straight in. Again, there's several solutions here. I'm going to show you several things. So this is one option. And again, if this is typically a gas furnace, you'll see set up like this. If this is, say, a air handler, you'd need to have a box under here with that going in. And we'll take a look at a couple things on that later on with some other configurations. Because a lot of times if you've got a box right here with an air handler on it, you want another set of turning vanes going across here to aim it up into that coil properly so that we get straight airflow going into the coil. And you'll see a neat picture on that later on as well.
Eric, I got another quick question.
All right.
Ricardo wants to know, I think I know the answer to this. He wants to know, can filters help get rid of the coronavirus?
That's a really good question. And there really is no answer that I know of to that. First off, in order for a filter to get rid of the coronavirus, we have to get the virus into the filter. So we would have to be pulling all kinds of air out of the room and through that filter. Can the coronavirus get trapped in filters? Yes. We can trap some of the coronavirus in those filters in there, and that's a concern we're going to talk about later in safety. But we can get some of that virus trapped in there, so that is a concern for us as technicians. As we're going out in the field and we're potentially changing these filters, we need to be aware and we need to be cognizant of that possibly being in there. You know, I'm not going to say that it is, but I'm not going to say that it isn't either, because there really is no one-size-fits-all answer.
And Ferris wants to know real quick, what kind of effect does a UV light have on air filter materials? Like what distance do you need to keep those away from the filters?
Most filters, and again, this is going to be filter dependent, but most filters are not UV stable. So if you have UV lights in there, you need to keep that UV light from shining on the filter. If you don't, what'll happen is you'll come back and that filter will look like it's been chewed on by mice. And it will just literally have holes in it, and you'll probably find those little flecks where it gets fragile, because it'll get fragile and stiff and brittle. It'll break off, and you'll probably find all that stuff downstream somewhere in the blower or the coil of the equipment. We good? All right, we're good. Thanks for all the questions. Keep them coming. That keeps JD doing something over here. We don't need him snoring in the middle of the show. All right, so on to the next thing, okay? So this is one option here. We can help with the turning vanes. Something else we can do is we can, if we have a gas furnace in here, we may need to expand this filter a little bit. So if we have a certain size opening, like a 16-inch high opening in the size of that furnace, which is pretty common, we may want to put a 20-inch tall filter on there. So we can put a short box underneath that furnace, and we cut out the side of the furnace and the side of that box, and that allows the air to come across into the blower, and some of the air comes across the bottom of the blower and can feed the opposite side of that blower. This is really important, and make sure you look at your manufacturer instruction manuals, because a lot of manufacturers want the air coming in the bottom after you get above a certain tonnage on gas furnaces. So that's an important piece, to be able to get that air across to the opposite side of the blower so that we feed that blower evenly. Because if we're trying to shove all the air into one side of the blower, it's not going to work, and it's not going to evenly distribute the air across the heat exchanger or the coil up top.
Hey, Eric, real quick, can you repeat your answer on the UV light?
On the UV light?
Yeah.
Okay, so you don't want the UV light shining directly on the filters. I think there's a couple filter manufacturers now that are making UV stable filters, but you're going to have to go back and talk to the filter manufacturer if you want to shine the light directly on the filter. My advice is, universally, do not shine the light on the filters or UV lights, any other wiring or anything like that. Now, we are going to be doing a show at some time in the future on UV lights as well, so we'll talk more about that during that show.
And then Stan just chimed in, or Jeffrey just chimed in. He wants to know, can you explain the velocity of which these filters are rated for, such as what high velocity means? Many people overlook this or don't know.
Well, high velocity is it depends on what it's relative to. Typically, when you look at manufacturers' charts, they rate them at 300 and 500 feet per minute is where a lot of manufacturers rate their filters at for the pressure drops. When I went back and started looking at the pressure drop charts for the sheet that I made up earlier on there for that filter selection sheet, to get the correct pressure drop, I actually found that my face velocities on the filters were typically somewhere around that 180, 190 feet per minute mark. So slowing that air down on that filter is really important. The thing is, okay, we don't want to go higher on our face velocity. We're typically always going to go lower to get that lower pressure drop. The blower motor doesn't care what the velocity is going through that air filter. The velocity inside the unit is fixed by the size of the unit. What we can control is the velocity going through the filter, but the blower motor doesn't care about that. The blower motor cares about pressure drop and resistance. How hard does it have to work to get the right volume of air in? So velocity through the filter really is not a primary concern for me. As long as we are at a low enough pressure drop, the velocity is going to end up low enough in that filter.
And then I got another question from Robert. He wants to know, how much exposure would it take for that sort of breakdown to be visually evident on a filter?
I have come across one where somebody installed a UV light incorrectly in line of sight with the air filter, and I don't remember the time frame that it was in there, but it had holes large enough. It was less than a year, but it had holes in the filter large enough that I could stick my fingers through it. So it was significant damage, and that's where it just got brittle and came apart. All right, because the filters, this filter media is made of plastic. All right, it's a type of plastic resin in there, and the UV light just breaks it down. It's just like leaving a plastic toy or something out in the yard, and eventually it gets hard and brittle, and it just breaks. All right. Okay, so box underneath, right, gives us the shape, the space to put a bigger filter in there, and you can put bigger boxes under here. You can move that box bigger. Again, if you have an air handler, you're going to have a big box, because the air handlers typically come in on the bottom because they're a draw-through coil. There's, I think, 1 or 2 manufacturers now that are making blow-through coils where they have the blower compartment on the bottom. Now, if you need more airflow, quite often, manufacturers, when you get up in larger tonnage in residential, light commercial, unitary equipment like this, you need to feed either from the bottom, right, or we need to feed from both sides of the blower compartment, bottom or both sides. And so we can feed from both sides like this, because remember, if we go back to that pressure drop chart, and we're using like that 2-inch, even that 2-inch filter, a 20 by 25 will run about 1,000 CFM, okay, a little bit over. So we're going to need 2 of those 20 by 25s in order to get a low enough pressure drop. Now that might surprise everybody when you look at that chart. It did me when I looked at it. When I started looking at the information, I was like, holy cow, I've been putting a lot of air filters on that were a little bit too small for a lot of period of my career. You know, I really should have been doing this a lot more often. Or things like this. Okay. Here's another option that I really like. Again, it all depends on the physical space and what we can fit in there. What works for the physical space. This is called a right angle box, and it allows us to put a 20 by 25 filter, something like this, okay, into a box that sits on the side of that furnace. And it sits in there at an angle so that we can just use that 16-inch tall opening, but still get the 20 by 25 filter size comes in and goes in. Now, in this case, the filter kind of acts like turning vanes, but not really. It is higher resistance to do this. It's not going to make a perfect turn, but we're not trying to go into the a filter over here. We're trying to go into that blower. And this picture is kind of misleading because when you do this, you really want those pleats, like this one is, running up and down so that we're not hitting one side of those pleats. So this is the actual way that would be. The pleats are going to set vertical in there. All right. And again, if you need more air, put 2 boxes on. Okay, again, that is if you've got height limitations right here. We can't put a box underneath to feed the bottom of that furnace. I might have to come in both sides. So again, more options there for you. These are all configurations that I've used and installed over the years depending on what was necessary with the job. I even had one job once where I helped a contractor out, and we only had space to bring stuff down on one side. This side had a wall on it. So we set the furnace up on a box, all right, and we had 2 of these right angles. We had 2 drops coming down from a big return trunk up here. We had one going into the side of the furnace, and then we set this up on a box and we had a drop come down. We had another right angle sitting down here with a duct coming off of it going into that box. So there's a lot more stuff in there depending on the physical space that you have with what you can do. Sometimes you have to get a little creative, but you need to make sure you're getting the air into the unit in a proper fashion and enough of the air. All right, now for an airflow standpoint, this is my favorite way to do it. Okay, nice big filter out here, as big as you can find. Nice sweeping radius turn. This is the most efficient way to turn air in a duct system. Sweeping radius. Okay. Then underneath the equipment, we're going to put the turning vanes in there. All right, and we're going to aim that air straight up into that coil so we have even airflow across our coil. Now, let's take a look at this. This was a system that I found obviously years ago. If you look at the date on that, it's been quite some years ago now. Right? I went out there to service the system to do maintenance on it, and I found that, hey, things were not right. First thing I found was, well, it looks like it's a little low on charge. Okay? So I go inside, I look at the filter. Where it was sitting inside, I could get the filter door off because the filter sat right here, but I couldn't get my head around to see this side of the coil without moving some stuff because of where the door was on the front of it. So I looked up inside and I saw a nice clean coil. I said, hey, great, the coil's clean. I never could get it quite working right. I scratched my head. I went back inside to double check myself, make sure I hadn't, and I got my head farther around in there, and lo and behold, half of that coil was frozen. Frozen solid over here, where this half is perfectly clean. This was the duct configuration on there. Okay, so we've got the airflow coming down here, but there's no turning vanes in either one of these corners. So when this air came over here, even though the filter was here, most of that air split and went to the left-hand slab, had a small refrigerant leak on it, got a little bit of loss of charge. So my saturation pressure dropped, I low airflow through this side, plenty of airflow through this side froze up. That was an interesting find. This was probably one of the first times I realized how hard it is to make air do a 180-degree turn in like 6 inches. It's really hard to do. Again, we actually did go back and fix that system by adding 2 sets of turning vanes in there to make sure the air made that turn. And lo and behold, the system started working a lot better than it ever had. But it's things like this that we can't necessarily see. We got to be aware of, though, because it's hard to see that air moving in there, right? Okay. Now, again, this system we talked about earlier a little bit. You've got the filter grills out here. And again, I said we need to make sure this is all sealed from the filter grill to the unit, whether this is a package unit or whatever. Something I want to caution you about is on package units, a lot of them have a fixed filter size, fixed filter rack size in them from the factory. You need to find out what kind of filters the factory designed that system for, because if you go trying to raise that up to, you know, like this filter right here is a Merv 13, I believe. Yeah, Merv 13. If you go say it's designed for a Merv 8 or it's designed for a poly filter, right? And then all of a sudden we go throwing a pleated filter, Merv 8, Merv 12, Merv 13, whatever in there. Suddenly that filter rack is not going to be big enough. You may need to move your filter out of the unit, bring it back to filter grills to get enough filter surface area, or find some place in that duct to mount an external filter rack if the customer wants increased filtration. So that's a concern, and it's a good use case. Now you can get 2 and 4 inch versions of the filter grills like that. They are available out there. I don't think there's a lot of distributors that stock them, but get with them. They are available from some manufacturers. All right. Now, as I promised, HEPA bypass. Okay, so we're talking about HEPA bypass. Our normal path, our normal flow of air is going to be through the equipment. The HEPA bypass filter over here has the HEPA filters, and it also has its own fan. Okay, so it's going to pull a percentage of the air out of the duct, run it through the HEPA filter, and run it back into the duct prior to the other filter. This is how the designs and the diagrams go in the installation manual. So it's another option. It filters a percentage of the air, so it takes a lot of the particulates out of a percentage of the air. This becomes a lot more efficient if you're running the fan constantly in the blower. So just keep that in mind if your customer wants really good filtration. If you're going to go to the work to put this in, make darn sure all your ducts are sealed up. You want all these ducts all the way back sealed up, because you don't want any extra dirt coming in there. And if they're in a space where it can get any dirt in, they're going to bring that dirt in there. It's just going to add more dirt into stuff. So make sure all your ducts are sealed up. All right. We got some more questions, JD. Of course we have time for questions.
All right, Robert wants to know what changes when you're dealing with a heat pump instead of a gas furnace?
What changes when you're dealing with a heat pump?
As far as filters.
As far as filters, nothing really. Make sure that they are sized properly. Again, you need to look at that total external static pressure. Some heat pumps have enough capacity that you can maybe take that up to a 0.15 or so. It really depends on that total external static pressure. I much prefer just to stay at the 0.1 design resistance or design pressure drop and use that universally across the board, because it's just easier, and I know that too big of a filter is not going to hurt me on that.
Right, and then he had a follow-up question that when the customer's filter is not square, how do you spec a slanted filter so that the pleats are properly aligned? Which are the size dimensions, larger or smaller, is the direction of the pleats?
Very good question. And there really is no good answer because I've seen manufacturers make them both directions. So I really don't have a definitive answer. You need to look at the manufacturer, talk with your distributor, and whatever manufacturer they are using for air filters, take a look at that.
And then Jess brought up a point that a lot of his customers change their filter when they hold it up to the light and they see light go through it. Mm-hmm. When's a better method to realize when to change that filter?
So we're going to talk about that here. Okay, so we can do a couple different ways. The light method, I can see a light through a pane of glass too, but it actually makes a really good air filter. But the problem is it doesn't pass any air at all through it, right? So it has really, really high resistance. In fact, it's not going to let any air through. So there's a trade-off there. Yes, we can still see light through it. I like to do things on resistance, and we'll talk about that here in a little bit, and I'll share some stuff with you on that. Okay, so that brings up the next slide. When do we replace a filter? Okay, do we do it on time or resistance? It depends on the situation. I've had filters in my own houses. One of my houses, I could run that filter for close to 2 years before the pressure drop started to get to the point where I needed to replace it, before the pressure drop started increasing. It really depends on the dirt load coming into the house. I like to replace it either when the pressure drop goes up or 1 year, whichever comes first. Because if I'm getting stuff out of my house in there, chemicals or whatever else might be in the house, I want to get that out, get it taken away, and get a new filter in there at least once a year. So that really depends. What I tell people when they're starting to look at filters, most filters are a white material, right? So when we start to see that white turning to a different color, okay, that's when I want to change that filter. If I start seeing dirt load on it. When I have a new system, I will teach my customers, if they're going to change their own filters, I tell them, I said, once a month when you get your power bill, go look at your filter, wherever it might be. When you start seeing a dirt load on it, that's the interval you need to start changing your filter at. And I recommend that they do that for a year, because some customers, if you're in the spring or fall, depending on what part of the country you're in or what climate you're in, maybe in the winter, maybe in the summer, you're not going to run your equipment nearly as much. So they need to get a good year's worth of data on it and then figure out how often they're going to change their filter. Or if it's a larger filter and a really clean house, it doesn't get that much dirt on it, have them change it once a year, maybe every 6 months when you're doing maintenance. It depends on how fast the filter gets dirty, really. So,
got another question for you.
Got another question. All right.
It's going back to the HEPA bypass. Is that something that would be added if we needed more filtration, but preferably a last resort? Question mark.
That really comes into play, in my opinion, if a customer is really worried about very small particulates. And because of the high rate of filtration for it, it is a little bit of expense, but it depends on what the customer's needs are. If they don't have a lot of dust allergies and they're not super concerned about that, I don't think I would recommend to them to install a HEPA filter. Now, if they want it and they're willing to spend the money, am I going to put it in for them? Yeah, because that's what they want. That's what they desire. And typically in the HEPA filters, they're going to have 2 to 3 filters in there that some of them need to be replaced annually at minimum, and some of them need to be replaced every 2 years. So they'll have a primary and a secondary filter in there. So they'll catch most of the dirt on the primary, and then the secondary filter typically lasts longer.
Constantino wants to know, do you know how to calculate the energy savings from one filter to the other? These are tough questions.
Energy savings? Well, that really depends on the blower motor. But you know what? I do not sell products on energy savings. It is typically, by and large, a losing proposition in today's world. Unless you're making a really big jump on something, it's going to be some energy savings. Now, if I am looking at going from, say, a 16 by 25 to a 20 by 25 air filter, yeah, I'm going to save that money, but I really hesitate to promise anybody energy savings because energy rates fluctuate so much at times, and we don't have control over that. So I'll say energy usage, yes. If you look at the watts of the motor at one resistance versus the watts of the motor at another resistance, you can kind of figure that out. But how often is that motor going to run at those watts? Especially if you're talking about like an ECM, where they will change constantly during the runtime. So it becomes really challenging to talk about energy savings with regards to filters.
Bob wants to know, what type of filters remove odor?
What type of filters remove odors? Typically, you're going to look for a charcoal filter. Now, you want to look at the filter and what kind of charcoal it's in it, and you want to find something with activated carbon in it, okay? Not just a carbon filter, because a lot of carbon filters will use it's a burnt plant matter in them, and it's really not that effective for very long. Versus if you get activated carbon, it's going to last longer in there, but they're more expensive and they're harder to find.
That actually answered my next question, what the charcoal filters was. So those
All right.
take care of the odors.
Hey, we're doing good. Excellent. Now, obviously, these filters were in there just a little too long. The guy that gave that picture to me said he thought they were in there about 5 years, so could have been changed a little bit before then. All right, again, once per year or when the resistance increases. And what I like to do on that is I'll take a Sharpie or maybe put a sticker near that filter, and I'll write down what kind of filter is in there, right, in case the customer or somebody else puts in a different filter. I'll say, hey, this is a Merv 8. Here's the size, and here's the pressure drop when it was clean. And that way, when I'm coming back to do maintenance later, or I'm coming back to troubleshoot a problem, I've got all that information there, and I can make a comparison. I can say, here's where it should be when it started out, here's what it is now, right? And then we can make an accurate recommendation to the customer saying, your resistance is too high, the filter needs to be changed. But if we don't have that preliminary data, we have nothing to compare it to other than we're guessing that it's too high. We can put a new clean filter in there, right? But if it wasn't designed with that filter originally, who knows? So again, make sure you got that initial data, record it right there next to your, put it on the ductwork somewhere, or put it on the filter rack, somewhere close to that. Make it easy for you to get a hold of. All right, that's a great way to do that. And then you can give your customers reports whenever you do maintenance, if you're doing maintenance for them. All right, now, let's talk about safety, PPE, personal protective equipment. All right, so this has actually come forward a lot more with the virus going around right now, okay? Because the virus can potentially get stuck in that filter. And you've also got dirt and who knows what all else in there. I mean, you could have, if there's people in the building with the flu or the common cold, anything else, it can all get up and float through the air and get stuck in that filter, right? Probably want to have a mask, some glasses, some gloves. This is one that I kind of use once in a while, but I really should have done a lot more. All of these. Disposal bags. You figure we pull this, we pull a filter out, and if it's loaded up pretty good with dirt, then we go traipsing through the house with a dirty filter, right? We can shake that dirt off everywhere, knock it off. Who knows what's going to happen? It's not very much space to take a plastic bag down with us. And some filters that are shipped in plastic bags, you can just pull the old filter out, drop the new filter down in. But if you don't have that, it's a good idea to grab a plastic garbage bag, something like that, take it down with you. Throw that filter in there. Take it out. Because the other thing is, and I know I've done this, I've thrown dirty filters in the back of my truck, and guess where all that dirt goes when I'm rattling down the road? Well, it knocks off, and then it's laying down in the back of my truck. And I got a messy truck, I got to clean that up later. Well, if I just have it in a plastic garbage bag, slide it in there, take it out, throw it in the dumpster later, and I'm done. So that's a really good idea. Now, I think the next thing we've got coming up is our poll, right?
Before we get to that, I do have a few questions, though, before we get to the poll question.
All right.
Richard wants to know, are hypoallergen filters a fact or fiction?
Well, so hypoallergenic, what is that really? But yes, they will capture more stuff. When you see a filter that says hypoallergenic, typically it's a higher Merv rating. The higher the Merv rating, the more stuff it's going to catch and it's going to grab onto. Now, if you don't have sealed ducts or you have pressure differential in the house, that filter's not going to do you a whole lot of good because you're going to be bringing in those allergens from somewhere else. If, say, you have a leaky duct with filter grills on there and somebody takes out the Merv 6 or Merv 8 filter and throws a Merv 13 or Merv 15 filter in there, the allergen filters, you're going to change your pressure in that whole duct and you're going to suck in even more stuff into that duct, which means it's going to blow it out into the house. Anywhere between where the filter is located and your fan needs to be as sealed, as close to 100% sealed as you can make it to keep those allergens from coming in. Hopefully that answered that question.
Doug wants to know, does ozone recharge the charcoal filters?
Does ozone recharge charcoal filters? I don't know about that, but I seriously doubt it.
And Gus wants to know, with humidifiers installed on a return airdrop, does it affect the life of the filters?
That really depends on if you're getting a real high humidity coming back in there and it can actually weaken the cardboard frame on the filters, is what I have seen happen. It can also put some dirt from the pads into it, which of course loads the filter up quicker. However, does it shorten the life just because of humidity? No, I really don't think so. You'd have to get some super, super high humidity in there for a really long period of time. Where you're using bypass humidifiers, you're always going to get some humidity coming back into that return. So, all righty, we're good? Okay, we're going to go on to the poll question, and here comes JD.
How are you, Eric? Thanks. You can stay
good.
on here for this one because
sure.
I'm actually interested to see what the results are. So, for buying filters, and I want to get your opinion on this, who should be sourcing and installing the filters? What's your answer to that?
What's my answer?
What's the best answer from Eric?
My answer is there is no right answer to that.
Oh, okay. Well, let's find out. I don't know if that was an option or not. The contractor or the homeowner?
Okay.
If you had to pick, which one?
Either or. Depends on the situation.
Wow, okay. That's not the direction I thought you were going. Okay. Oh yeah, we need to give you time to fill that out. Yeah, so now there is a window. I thought it was already done. There's a poll on there, and we want to know who would be sourcing, who is the best to source the filters and install them. Eric says both, which is kind of a cop-out. So we need a real answer. So if you can fill out the poll, we'll get the results, and we'll post those up here as soon as Tyler gives me the go-ahead. But you're thinking that either or just depends on the situation?
It really depends on the situation.
When is the homeowner, and what situation is the homeowner, it's okay that they can install and they know which filter to pick?
Well, sometimes, one, if the contractor tells them how they design the system, which we should be doing that to communicate properly to the homeowner is competent, they're mechanically sound, they understand how to either buy it or source it from a contractor, order it from FilterFetch, to get that filter to put it in properly, right? I think there's a lot of homeowners out there that are perfectly competent and able to do that.
Right.
Now, if the homeowner is not, they physically can't get to the furnace or where the filter may be, they physically can't get there, they can't do it, they don't want to do it. Some homeowners flat out don't want to do it.
Right.
They want to pay somebody else to do it. Then I think, they have the contractor do it. So okay. I get very hesitant when people want absolutes like that because there are very few absolutes in the world to me.
Our sales director hates absolutes.
He
hates them. He always corrects me when I use absolutes. All right, we ready to get to the poll? Okay, so it looks like, 67% say the contractor. I would think so, since we have a bunch of contractors on here. But you know what? That's actually a lot lower than I thought it would be. I thought it'd be like 75-25. but it's pretty close. 67% say the contractor and 32% say the homeowner.
Well, like, we were actually talking a little bit about this earlier before the show, and as a technician, it's challenging to carry filters in the truck, and there are so many filters. I mean, look at the space, the number of different filters you have out in your warehouse back here.
Right.
How can I carry one or multiples of each one of those on, a regular van?
Right.
Or even keep them warehoused in my warehouse? So sometimes, especially if it's an oddball filter, yeah, I might have the homeowner take care of it.
Yeah.
So
well, that's
it
where
really
FilterFetch really comes in handy. Is we're taking away all of those cons. And here's actually we've got some bullet points that you kind of talked about here, as far as comparing, the pros and cons of having the contractor do it. I mean, obviously, getting that peace of mind that a professional is recommending a filter, that's definitely a pro. And also if you installed it, it's done correctly. There's less chance the homeowner could damage the equipment, especially, one of the things about FilterFetch, we have the option of shipping a year supply. That is a pro, but I would say a con is if the customer kind of just throws them in a closet or really doesn't understand how to treat those, because they can get damaged, and like you said, they can cause some leaks. So that's a con too. But it's also a huge pro. It's revenue stream too, because if you're the contractor and you're offering this system and the customer buys in, that's just a reoccurring revenue for that business to keep them up to speed with the filters, make sure they're changed and they arrive conveniently, and the contractor just has to sit back and collect a commission check. And it's a reason to schedule, routine maintenance. It's a reason to talk to your customers. Yep. Be top of mind too. Now, here's some of the cons of having the customer take hold. I mean, you're going to have to spend time you're going to have to spend time going to the wholesaler, not using FilterFetch. I mean, it takes a lot of room on the truck, like you said, and easily damaged, because we were actually talking before this, just like you actually had to design a specific cabinet space to stock filters on the truck.
I did. When I was in a service truck, I actually made in I can't tell you how many different, three different service trucks. I made a large filter shelf just to be able to put these big filters onto the truck and not damage them. Because the worst thing I had with filters on the truck was I pull them off, they're smashed, whatever, right? Then I go to slide them into that rack and I'm bypassing air, and then I'm defeating the purpose of having a filter in there.
Right.
Now I'm just getting the equipment dirty by letting all that air go around the filter. So there's a lot of trade-offs on there.
Yeah, exactly. Some of these guys are maniacs on the road too, trying to get to the next install.
It is.
Swerving all over the place because it is light. I mean, it just tumbles and falls, and you do not want anything to happen.
Well, and if they're all setting in the middle of the truck, something falls off a shelf, or you have to move them out. They get wet. The cardboard gets wet.
Set your tool bag on top of them.
Set your tool bag on top of them. These trucks are not getting any bigger. Well, okay. Some of the trucks nowadays are actually getting bigger, which I'm happy about, because I love a large truck to work out of.
Right.
But then they don't fit in some places. They don't fit in a drive-through or a parking garage or something like that, depending on where you're working at.
Right.
They're harder to park in driveways. So there's a lot of pros and cons to that, and being able to fit filters in a van is a big piece of being a service technician, especially in the residential and commercial world.
Right, and then the contractor having to buy filters too. I mean, the homeowner can just go online too. I mean, if you're giving them that power, if you're giving them the ability to shop on their own, if you're not owning that situation where you're like, I'm the professional, this is the filter you need, instead of just saying like, hey, you need this size, it's a real pain to go get it. You can find it online.
It's also what the system is designed for, right? Like we talked about. If we put in if the homeowner goes down to the hardware store and grabs, I want this big allergen filter, but they don't realize, hey, I'm adding a bunch of resistance to this system. Now they're changing the design characteristics of that system.
And they're going to be uncomfortable.
Potentially.
And then they call and they're going to be uncomfortable. They have to pay you about $100 to come out there to fix an easy situation that could be avoided the entire time.
Could be, yeah.
By just taking the contractor's advice and not just saying, hey, just go buy this, not even deal with it.
Yeah.
And then, there's low margins too. I mean, you're taking away a lot of costs with FilterFetch by just shipping the filters directly to them, because, I mean, we talked about this too, how some techs would run out to the house, and if they did damage it or they brought the wrong size, you're losing half a day now because you got to go all the way to the supply house. You got to go get that if they even have it. And then you got to go back. And now that customer's mad because they showed up and they didn't have what they said they were going to have. And they requested off work.
Yep.
Let's pretend that people used to go to work and not working at home anymore. But they had to stay home, just like the cable guy. They had to wait. And they had to take time. And that's going to have a long-lasting negative effect on your company by not being prepared. And FilterFetch kind of gets rid of all that by you not only owning it, but using a system like that.